Very cool. I think we can get started. How is everybody? Welcome everybody to this May community call. We're super excited to have everybody here. I see so many GMs, so many welcome in the chats. Keep them going and keep asking questions. Let's doing quickly round of like intro of who is hosting this call right now. I bring you on stage, Eric, on spot. Like quickly introduce yourself so that everybody know who are you.
Yeah, absolutely. So my name is Eric. I'm one of the DevRels on MetaMask, and I work with pretty much anything developer relations in and around MetaMask. And today I'm going to be presenting on EIP 6963, doing a quick demo, showing people how they can kind of create multi-wallet, multi-injector provider kind of stuff from scratch, but also talk about some of the third-party libraries out there that you could use as well.
Sounds good. Thanks, Eric. Yeah, by myself, I'm part of the developer team at Consensus. I'm super excited to be here. So let's get it started. So what we'll talk about today, we will just give a quick overview on the around MetaMask developer offering and what Snaps is all about. Then we have a deep dive with Christian Montoya around the requirement changes of our allow list and some cool stuff around the interactive UI. Eric, as you mentioned, he will speak around 6963. So quite exciting. And then we have some dev showcase. I will not speak more about that, but both Jenny, Jackie, Ton, and Tony will speak a little about those DM1 challenges and hackathon wins. And then we have some Q&A and updates and some recap. So for anybody that's never been a community call, feel free always to ask question anytime. We're more than happy. Feel free also to either raise your hand or like just DM questions to us if you guys have any on this specific topic. And those calls are basically happening monthly. It's a mix of like product updates, developer showcase, and hackathon winner. We're super excited to always host those calls with everybody here. Cool, let's get it started. So for any developers out there, and feel free to DM or like just write I'm a developer in the chat to see how many developers we have in the room or just seeing the live streaming. But today we have three main offering, as probably like you guys saw in hackathons or just around our channels, Wallet API, SDK, and Snaps. We will deep dive a little bit everything Snaps today. And for anybody that never remember or never used or never installed or never built a snap, those snaps are basically like extra functionality that you can add to your extension. And everything is quite possible with snaps, right? Think about different use cases from like interoperability, so like non-EVM compatible snap. I don't know how many of you guys install, for example, there is a Solana snap, there is a BTC snap, so everything that has to do with non-EVM compatible, that's basically the interoperability snap. And then you have different other snaps type, from like notification to transaction insight. Security snap is one of my favorite, and then everything that is around privacy. I think Christian will deep dive a little bit more on that, but just for everybody that wanna see which snaps are available today, you can check those 50 plus snap in snaps.metamask.io. And and for anybody that is building snaps, like there is a bunch of like tutorials, example repos, and different snap being built that you can use it and build on top of it. Just a little bit like quickly. So every snap is fully isolated, meaning they have their own data and their own interaction, meaning every permission, everything that you will see on Snap is fully like transparent, right? Even when you're requesting access to a Wi-Fi or specific like extension permission, right? Think about, this is just an example, that's the Wallet Guard Snap, and you can really see like fully transparently who built the Snap, who is the author, where is the source code that you can actually DD yourself, and what's the permission that being requested. And here is just a screenshot that you can see what are the specific permission. And as mentioned before, even the Snap accessing the internet is something that you wanna see. And so it's really permissionless innovation at its best, and transparency here. It's the focus. So just to recap, Snap self-custodial. all those snaps will live in your wallet. So anytime that you are in a couple of steps installing this snap to your extension, you will see this snap being installed in your setting. And then also like every snap that you install and you want to give permission and we want to revoke permission, it's all up to you, right? So it's quite powerful. This is just a quick QR code for anybody that is I want to check out what snaps are. But basically, like you see all our snap allow list there on snaps.metamask.io, and you have main those 4 categories: interoperability, security, communication, and account management. For the developers in the room, it's quite easy to start with Snap. And we put here a couple of like links. This QR code is redirecting you to the Snaps Builder link, where you have a bunch of like example guides and video from our not just from our like Ziad, our Snaps DevRel, but other people that we support. Cool. I think we're getting there. I will give you now the word to you, Christian. Yeah, I will just toggle you on stage. So welcome, Christian. Feel free to introduce yourself so everybody that doesn't know you will know you better.
Thank you. So I'm Christian. I'm one of the product leads at MetaMask, and I'm here to talk about some of the product updates that we have for the Snaps platform. And I think for this portion, I'll share my screen.
Yes, please.
All right. So same slides here. And here we go. So one of the things that I'm excited to share with everyone is that we've updated our allow listing process for snaps. And I know we had a question in the chat about how long it takes for a snap to get reviewed for allow listing. It's usually about 1 week. So hopefully that helps. But some of you who are building snaps may be interested to know more about this. So allow listing is how we make snaps available to users in the MetaMask extension. So we have MetaMask Flask, which is a developer tool where you can test your snaps and you can install any snap that's currently available. And then there's the MetaMask extension, which has over 30 million monthly active users. And that's where users can actually access all of the great new features that are built with snaps. And so we actually manually review snaps before they go into the allow list to make sure that they're safe for our users. Up until now, every snap has to also get a third-party security audit from approved auditors that we work with. And that makes sure that the snap doesn't do anything unusual. It doesn't leak any data or expose any user funds or anything like that. We actually have a new allow listing process. So we've been working with the auditors on our allow listing process, as well as our own in-house auditing group, Consensus Diligence, and reviewing all of the audit reports that have come through and working with developers. And we've identified some ways that we could simplify the allow list process while still keeping users safe. So the new process works like this. If a snap is using account management permissions, if it's generating keys for, let's say, Solana or Cosmos or Bitcoin, it still needs to have a security audit before we review it for allow listing. Okay, so those snaps will continue to receive third-party security audits. So any snap that does MPC wallet functionality, two-factor authentication, or adding support for another blockchain network, those will continue to receive security audits. If a snap is using what we call protected permissions, and it's not doing any account management, it's just doing things like network access, communicating with websites and so forth, it does not need to get a security audit anymore. So you don't have to pay for a third-party security audit or request a grant to cover that cost. You can proceed straight to being reviewed by the MetaMask Snaps team. So you can now submit your snap for allow listing without having to go through this auditing process. Now, if a snap uses what we call open permissions, these are very simple permissions, such as displaying content in a UI, maybe storing data, doing basic execution like cron jobs. Those can actually be installed without allow listing. So that means that now there's a subset of snaps that are fully permissionless. This means you can build your snap, users will be able to install it into MetaMask, and you don't even have to go through the manual allow listing process anymore. And in a little while, I'm going to show an example of a snap that does this. So we're really excited about this because we've been wanting to make at least a portion of snaps fully permissionless for a while, ever since we launched. We actually launched Snaps at the Permissionless Conference. So this has been a huge goal for us. It's how we're enabling permissionless innovation for users and for developers. And now we have a category of snaps that are able to be fully permissionless. You don't have to go through us in order to get allow listed. Users will just be able to install your snap in the MetaMask extension. Also, we've recently shipped what we call interactive UI. So you can now build interactive interfaces in your snaps with dynamic UI components, things like forms and buttons, and we'll soon be adding drop downs and other types of interactive components. And so this means that you can now have embedded dApp-like experiences in a Snap homepage or transaction insight, and soon we'll have this functionality in dialogues as well. So you can make snaps that respond to user input, and you can actually build interactive interfaces inside of a snap. And so I have a URL here that takes you to our interactive UI documentation, but I also have an example of a snap that does this. So I built this snap called Mystery Fox, and I think you can now see this in MetaMask. I already have it installed, but the way you interact with Mystery Fox is you open the snaps menu. So you go here. This is Mystery Fox. It has this little purple mystery ball. And I can ask the Mystery Fox a question. So I can ask it like a yes or no question. Let's say, is this a good demo? Click query. And it will actually return in a dialogue an interactive interface. Okay, so the Fox responds. It says confirm. This is actually an SVG. I can go back and I can do it again. I can say, will it rain today? Query. And it will say, unsure, ask again later. Okay, so the Mystery Fox is not, a weatherman. He's not doesn't know anything about meteorology, so he can't help me there. And so I actually shared the source code for this. So when you go to this website, you can actually open the source code and you can see how it was built. And essentially, it uses our interactive UI methods in order to update the interface in response to user input. So there's a few different methods: create an interface, update the interface, on user input, get the interface and return a new interface. And you can actually interact with what the user does, with the state of buttons, the content of input, and so forth. It's very similar to building an interactive interface in a website. And so we've built this so that you can actually build these really fun interactive flows and use cases. You can build games, you can build simple snaps that return information. You can even build more complex things. You could essentially build a swapping interface or a bridging or staking interface inside of a snap, a whole account management interface. Let's say you could build a snap to manage your ENS domain names or something like that. You can actually do all of that now with interactive UI within snaps, and you can really customize and enhance the user experience in MetaMask. So that's an example of that. This is also a snap that is permissionless. So because it only uses simple UI and it doesn't do any sort of like network access or account management, anyone can install this into MetaMask. It actually is not on our allow list. So if you go to this website and install it, you can actually install it into the MetaMask extension. All right, and if you go to this QR code, it'll take you to that website that I just showed you where you can play around with the snap. So I also want to share that we've been updating our snap stocks with guides for all of the different features. You can learn more about how to use snap homepages, dialogues, transaction insights, custom UI, interactive UI, all of the different components that are available. You can go to our docs and just go to the features section in snaps. And you can find all of the guides that are currently available. So we now have feature sections for all of the different things that you can use in snaps. And they show you examples, example code, how to use it, all of the different features that we offer for each API, as well as links to example snaps that show you how to use these features in depth. All right. Last but not least, you can find all of the available snaps currently at our directory. So this is a QR code that can take you there. And we also have a builder engagement program. So if you go to go.metamask.io/snapsbep, or you follow this QR code, we have a builder engagement program that you can join. We have a team that's ready to support you on your journey. They have many tutorials. They can get on calls with you. They can join you on Telegram, help you through any issues that you're having. You can ask them questions, and they will also walk you through the process to get allow listed when you're ready to do that. And I think that's everything that I have to share today.
Yeah, nice. Christian, thank you so much. Thank you so much, Christian. I actually have we have a couple of questions in the chat from Martin here. You know, are you going to make the amount UI components available with green and red background colors?
Yeah, we're slowly adding all of the different components that are available. We're also adding some basic like theming and templating features. So I'll have to get back to you about that specific component, but we do eventually plan to make it possible to build sort of like confirmation and like swap or DeFi flows in Snaps. So one thing I would say is that you can go to the Snaps discussions section in our GitHub, and you can share which UI components you're interested in so that we can prioritize which ones to add.
Sounds good. I'm just literally bringing the link here. Any specific question that we heard quite a lot during ETH Denver, like any specific use case that you're excited about that are coming next, apart those categories? Obviously, we cannot tell much, but anything specific that you see builder wishing for or just building on top of?
Yeah, so I mean, we had someone who was asking about notifications, and we do plan to eventually add, like from MetaMask, like notifications for wallet activity. But there's a huge opportunity for developers to build snaps that do their own notifications. So let's say you have a Web3 gaming site and you want to notify a user when they have a new, like someone's challenging them to a game, or they have a new friend request. That's one thing that they can do with snaps. They can actually build those notifications into MetaMask. Also, let's say you have a DeFi website or an NFT website where users can make offers on NFTs, and you want to notify them when their offer is accepted, right? Or, you know, they can open a position. You want to notify them when they're about to get liquidated. You can actually build that into snaps as well. So you can build notifications for all kinds of use cases in your dApp or your product, and actually help users to stay engaged with your dApp through snaps. There's also a question about whether snaps will be secure. So we talked about that a little bit earlier, but essentially we've built the snaps platform to restrict what a developer can do, and help ensure that users, you know, their private data, their MetaMask accounts and so forth are not exposed to snaps. And we also review all of the snaps that are allow listed and are available in our directory. So we make sure that they're not doing anything unusual. So, and when you install a snap, you can look at the source code, you can look at the permissions that it uses. Okay, so you can see what is it exactly that the snap will do, and whether or not it's safe to use. And essentially, for anyone that doesn't know, snaps are applications that you can install into MetaMask extension. They add all kinds of new features. And so you can use snaps to add things like different account types, support for different blockchain networks, new security providers, so you can add more security providers to MetaMask, as well as new communication features. So if you explore the Snaps directory, you'll find all of these new features that you can install into MetaMask. You essentially install them with one click, and you enhance your MetaMask wallet with lots more features.
Sounds good.
So
thank you so much. Go for
I
it.
can have like a kind of recap and a few questions real quick, just to make sure that kind of I understand everything as someone who doesn't build a lot of snaps. So we've had questions like, what are snaps? Are they secure? Snaps kind of are like a black box when you start off. And as you kind of extend the MetaMask functionality, and you do various things in your snap, the user of the snap has to kind of approve of being able to do each of these things, right? So as you kind of build more things into your snap, you're kind of opening up these various doors that, again, the user has to kind of agree to, correct?
Yeah, exactly. And so the user is always in control, right, of what they're consenting to, whether a snap can do certain things like access the internet or store data within MetaMask or anything like that, right? The user has the ultimate control over how a snap will modify their MetaMask extension and interact in different ways. And so I like to think of it as like, you know, snaps are like wallet Legos, right? They allow developers to build all sorts of new features into MetaMask that plug in different ways, that they can connect in different ways. But ultimately, it's up to the user whether they want to take one of those Legos that a developer has built and plug it into their MetaMask extension.
Yeah, and I think the best way to kind of get introduced to snaps is to go to the snap directory, install like one of the wallet guard snaps or something, and start using it to kind of see how a snap operates in the wild. And then you might get ideas of how to build something that maybe doesn't exist. And for that, in that case, you have the Snaps discussion board on GitHub to kind of interact with the community, which we put the link into the chat already. And then also you said that for snaps that don't require kind of to be managing private keys, those are kind of easier to build, and they don't they don't require auditing. But you guys still take a look at any of the snaps that are built that we kind of suggest on the directory, correct?
Yeah, exactly. So any snap that's submitted to be included in the directory, even if it doesn't require a security audit, we still test it and look at the source code and see everything that it does, just to make sure that it's not doing anything unusual or unexpected.
Sounds good. I think we're good. Thank you so much, Christian, and definitely looking forward of what's happening next. Yeah, let's have now Eric. Thanks for the questions. Let's hear a little bit about 6963. It was one of the hot topic also from last week here in the Berlin Blockchain Week. And yeah, I think you want to share your screen, right?
Absolutely. Let me just make sure I'm selecting the right one here. Okay. So everyone can see my screen, correct? All right, so I'm gonna do a quick prayer to the demo gods. What I'm gonna try to do is step through in about 10 steps how to kind of create a dApp that connects to various wallets that might be installed into my browser. So you can kind of see right now that I've got MetaMask, I've got Rabi Wallet and Coinbase installed. I'm only gonna connect to MetaMask, but what EIP 6963 does is it's something that you can build into your dApp or use a third-party library to get this functionality. And it basically discovers all of the injected providers. So each of these wallet you can think of as an injected provider, and there is a object somewhere that I can read in order to kind of find out which ones are there and connect to them correctly. So if I click on the MetaMask button, it'll connect to MetaMask. If I click on Rabi Wallet, it'll connect to Rabi Wallet. And this is actually a big step forward in kind of connecting to wallets, this kind of idea of discovering them and making sure the correct one is connected to. In the past, we've had issues with, for instance, wallets that identify as MetaMask or have the is MetaMask true flag, that sometimes there'll be a problem when trying to connect to one of those and it opening up MetaMask, or trying to connect to MetaMask and it opening up the other wallet. So this is kind of a thing of the past with EIP 6963. As I step through this code really quickly, understand that this is how to kind of build it from scratch on your own. If you wanted to see someone else out in the wild that kind of does this, I believe that Uniswap kind of has their own kind of built-in EIP 6963 functionality when you're connecting to wallets. So it finds out which wallets are installed in your browser. But also there's third-party libraries out there that can do it for you, so you don't have to go through all this. So if this seems too complex, don't worry. There's third-party libraries out there that I'm going to show off that can do this. But as a developer, I kind of want to know the inner workings of this and figure out how it works. So that's what I'm going to attempt to walk through right now. Again, quick prayer to the demo gods. And so first of all, what I'm going to do is I'm going to create a Vite.js application. I'm going to call it Wallet Finder, and I'm going to use React and TypeScript. And so let me just go ahead and activate this code here. So we're changing into a new directory and npm installing everything that needs for my Vite application. One more thing I'll show real quick is that I have this tinyurl.com, and I'll post that over here into the chat. So if people want to take a look at that, this will have links to the various kind of kind of links. So now that I'm kind of in Visual Studio Code here, I'm in a basic Vite.js application, and we're just going to kind of walk through, see how easy it is to kind of configure this on your own. But again, if it seems too hard, you can always use one of the libraries out there that does it for you. So first thing I want to do is I want to come into my app.tsx, and I'm just going to put some new code in here. I want to detect wallets. Basically, the only thing this application is going to do is to detect these wallets and spit out a bunch of buttons to connect to them. The way that kind of I've figured out how to do all this is I've gone into the actual EIP 6963. Let's find it here. EIP 6963. Oh, I didn't put that link on here. So there's an let's just search for it real quick. EIP 6963. So if we go check out this EIP, we can find all the information on kind of what EIP 6963 is, as well as I'll notice a lot of interfaces and suggestions on how to get this working into a dApp. Now, this is a lot of stuff to go through. That's why we've created this tutorial here that will walk you kind of through it. So understand that I'm about to paste in a bunch of types and interfaces, and these are going to kind of allow me to use this EIP 6963 functionality. So let me go ahead and do that real quick. So first off, we have provider info. So this describes the metadata related to the provider. So wallet ID, a unique identifier for it, the name of the wallet. This would be like MetaMask. And then also the icon. This is some type of an SVG that represents that wallet, right? So everything I need in order to create a button for someone to connect to this wallet. And as I identify each of those providers, they're each going to have their own wallet ID, UUID, name, and icon. So I'll be able to kind of iterate over those and put them on screen. We also have the old 1193 provider. And the reason we want to extend this is because we want access to this kind of request method here, as well as any of the kind of legacy methods that were allowed with EIP 1193 standard provider methods. We have a provider detail. So this basically just combines the metadata with an actual provider object, creating kind of a more complete picture in my application of how to deal with this info and provider at the same time. And then the provider event is just basically the structure of an event attached by a wallet to announce its presence. So each of these wallets kind of need to announce themselves through an event so that I can find them. I've also added an interface in here for an error. That's just to help me in my application. So we've got the types and interfaces that we need to go ahead and move forward. So the next thing that I want to do, since we're in React, I want to go ahead and create some hooks in here. The reason why I think this is kind of easy to do in React is because we have access to things like hooks. So I'm going to create one called store.ts and paste some code in here. Now, again, all of this is back in this page here. You can go and check out all this stuff so you can go through it. But what I've decided to do here, make sure that this is correct. I've added a bunch of comments in here just to kind of show you what's going on. So we need to declare this provider custom event on the global object, just so that our global object knows about that new event that we're using. We need an array also to store all of these providers in. So I'm going to go ahead and new up that array and just kind of leave it empty at first. And then this store here, basically, the store is an object containing two methods. The store holds the state of the detected Ethereum wallet providers, and it's implemented as an external store, so making it available for subscription and synchronization. This value function just returns the current state of the providers, and then subscribes to provider announcements and updates to the store accordingly. This is where all of our kind of announcements are being handled, and we have a callback to deal with that. And then we add the event listener, and we dispatch an event. So again, all of this is covered in the comments. You can take a look at it. I got to breeze through it though. So on to the next piece of code that we need to add. So we need to create one more hook in here. We're going to call it use sync providers. So let's see here, use sync providers, and we'll call it .ts. Make sure I spelled it right. And so this is just the use sync external store hook is used to synchronize the external store with a React component. So it takes 3 arguments, a subscription, a function, and an initial value. So we basically have all the pieces that we need. We have these two hooks, and we also have all of our kind of types and interfaces here. Again, we're doing this kind of from scratch. So this is a little bit harder than it would be to just use, for instance, like Web3 Modal or Web3 Onboard that kind of does all this stuff for you. But I think as a developer, it's kind of nice to kind of walk through this and try to figure out how to do it on my own. So then I can make up my decision on whether I want to try to build this stuff myself or use someone else's code. So in our basic app.tsx, this is our only component inside of this application. We have this providers div, which is basically getting all of the providers and iterating over them and creating a button for each one of them. Each button will have this handle connect and will pass in a provider so that when this handle connect is called, it's going to basically call ETH request accounts on, like, for instance, the MetaMask provider. So that's all that's going on here so far. One more thing, just to make this a little bit pretty, is I will add some basic CSS. Let's go ahead and add it right here. So we'll just replace all of this with my own CSS. And all this is doing is kind of styling my providers div. We're going to have a little MetaMask error div also, so that if someone is trying to connect and there's an error or they reject the connection, we'll have a little error pop up that we can dismiss if we want to. All right. So we have that kind of in place, and we can go ahead and try and run this and see what we have so far. Pull that over. So already we have, it's detected that I have 3 providers, basically 3 wallets installed: Coinbase, MetaMask, and Ravi Wallet. And let's just go ahead and check on MetaMask real quick, see if I'm already connected or not. And I want to disconnect it real quick. All right. So we've got the basics here, but I want to add a few more things in before kind of we test it real quick. So I'm going to add some more code that's going to take care of making sure that when I connect to a wallet, that it displays the address, basically the selected wallet. And I also want to create some state for our error messaging. So what I'm going to do here is I'm just going to replace everything above the return statement, and then we'll go over that real quick. So we're just adding some stuff here. So we still have our handle connect, but now that we want to have this idea of a selected wallet, we want to display that and potentially handle any errors. I've updated this handle connect a little bit to be able to handle that situation. I've also added a format address so that when I display the address, I can format it so it's not this big long string of characters. You'll see like the first 4 and the last 4 of the wallet. And then I have some basic state up here to handle the selected wallet, the user account, and the error messaging in case something goes wrong. Finally, I want to get rid of all these red arrows here. So I want to use this code that I've added here, use these various methods in state. So I'm going to just replace this return statement, and we will see what additional functionality we have here. So looks like all of our errors are gone now. So we still have our provider buttons kind of running over those. Also, if there are no providers found, we'll just show this div instead of the buttons. And then we'll have a little basic heading that says either X wallet is selected or no wallet is selected. And then we'll have a place to spit out that wallet, that selected wallet information. So we'll have the wallet name, we'll have the address formatted very nicely. And then we have this final div down here. Oh, what's going on here? Do I need another? Yeah, there we go. So this final div here will basically, if there is an error, we're going to detect that, and we're going to set basically a variable that will be either true or false. So if we get an error, it will be true. And this div will show because it'll add this style to the div, and it will change the background color. And if we click on it, we have this clear error function that will go in and kind of reset the error message here. So with all of this installed, we should be able to go back over to our application here. Let's just do a hard refresh just to make sure. I can click on MetaMask and boom, it connects to my wallet. I could have connected to either Coinbase or Ravi wallet. Once I hit next, confirm, we should see connected there. Another thing that I could do really quick to show the erroring is I can come in here and I can disconnect again. And then this time when we connect, we can reject it. So disconnect. All right, I'm going to do a hard refresh real quick. Connect, and this time I'll reject it so we can see the error handling in place. And boom, there we go. We get our error message. It's not the greatest error message, but it's showing something there. And if I click on it, it should remove that error message. And then I can just, this time I'll actually connect. And yeah, that's pretty much the demo. One thing I wanted to go back and kind of focus on really quickly is a lot of the information that you're seeing here is covered in this tutorial that we have in the tutorials section in the MetaMask docs. There's going to be a second tutorial here, probably within the next week, that goes a little bit further, right? So this application that we've built here, it has one component, right? This is not very real world. Normally I'd have some type of a frame component that has multiple components that are being loaded into it. And I might have different routes and so we need to share that wallet state among as many components as possible using kind of React context provider and kind of global shared state. So the next tutorial that you can see in the MetaMask docs will cover all of that, kind of taking it to the next level. And also another thing that we'll fix in that tutorial as well is kind of refreshing. What if someone refreshes the screen? Do I lose my selected wallet? And kind of how do I handle all these things? So building a real world app using EIP 6963, just for those who want to know. Outside of that, what I would say is that you can check out WAGME and Web3 Modal or Web3 Onboard. Both are libraries that do all of this stuff already so that you don't have to build all this stuff yourself. Again, my name is Eric. I'm the DevRel on the MetaMask team. Yeah, thank you guys so much.
Thank you so much, Eric. Quick question: like, do you see any specific like challenges or like lesson learned around implementing this EIP on dApps?
I mean, as always, whenever you're kind of when you're not using one of the kind of provider libraries out there already that kind of does all this stuff for you, there's a lot of just things to figure out. The basic implementation of it is fairly easy. There's a lot more information out there now. It solves some problems from in the past around kind of connecting to the wrong wallet and these race conditions around that kind of injected provider, kind of Ethereum object being kind of stomped on by multiple different providers. So it solves a lot of those problems. But if you do it yourself, like we're doing in that tutorial there, and kind of setting up like kind of like Uniswap has done and kind of building their own kind of implementation. Yeah. Am I back?
Yes, you're back.
Yeah, I'm just saying that kind of building it on your own, you're going to run into all of the kind of UI issues and things that you need to test for. You need to test to make sure that it works correctly. You need to check that you're handling errors. You need to, hard refresh that page and see if the state from the wallet is being persisted. So you might need to use some local storage. So all of these things that you need to do on your own, if you want like a custom implementation, are kind of handled by these third-party libraries. The reason that we teach how to do it from scratch is so that you just know everything. You know everything about how it works. You can implement it on your own if you want to, or you can, you can choose to use one of the libraries like a lot of other people do.
Sounds good. Thanks, Eric. I pinned this this blog post out, how to implement EIP in your Web3 dApp. Is there any resources that you're like recommending to any devs out there that are kind of like cool to see when you're like trying to get a little bit more information about this?
Yeah, so if you search EIP 6963 in my name, you'll come up with a, there's, I guess, a post that I did a while back that's very thorough. However, my suggestion would be just to visit the MetaMask docs. We have a wallet interoperability page, and we have that tutorial. And through those various pages and source code and stuff that you find within those, I reference a lot of the other kind of resources that I think are good for people to
Sounds
check
good.
out. Yep.
Awesome. Thank you so much, Eric. Great presentation.
problem.
Bunch of people, bunch of comment in the chat. Cool. I think we have another two small session. Let's get it started. So just wanna intro Tony and Jackie. Let me find you guys in the room. Tony, welcome. I see the Infura t-shirt. That's awesome. And then Jackie, there you are. So welcome everybody. Feel free to introduce yourself. Do you guys need screen share or should I go through my slides?
No, just go through.
Yeah, no need. Hi everyone, I'm Jackie from Infura Engineering, and just wanting to share a recent hackathon project that we did. So next slide, Francesco. Here we created a frame app for Warpcast. So if you have Warpcast on your phone, you can scan this QR code and it'll open up a frame so that you can create art in a fun way with your friends. And so this is called Pixel Pact. And then, so I'll just give everyone a chance if you want to scan this with your phone. And then I'll pass it on to Tony.
Okay, hey everyone, my name is Tony Chen. I'm the product lead for Infura. So by day, I am working on Web3 infrastructure, but I also have a background in social and consumer apps. So this was a fun little hackathon project for us to work on together. If you go to the next slide, I'll just show you a screenshot of the Farcaster frame that we built. Yeah, there it is on the left. So if you're not familiar with Farcaster, it's basically a social network. Decentralized social network. And there's a lot of crypto folks on there, but one of the primitives that they've enabled is this frame, which enables very basic functionality where you can put in text or you can click these buttons. So what we built was basically a way to contribute to basically a social pact that we call it. So if you have 4 people, you can each person picks a word and we send it into basically DALL-E, and then it outputs images on the right. And then the people who contributed can mint that image as an NFT. So very, very kind of simple application. And the idea here is that if you're building a dApp, you can build in hooks, social hooks into Farcaster by using a frame. So there's other use cases for frames include things like making transactions directly from the frame, simple slideshow, and kind of polls and other things like that. So what I thought I would talk about really quick was just some of the learnings, because on the surface this looks really simple. But some of the learnings that we had from building this, you might be able to take away as you consider building your own frame. So one of the things that we did was try to make it so that you had to collaborate with other people. And while that can also be really nice and viral, we also found fun in being able to make a single player experience where you actually get the result right in the frame itself. So as you consider building a frame like this, consider actually having the payoff right in the frame itself, and then make it so that you can share that to other people, to all your followers, so that kind of spins up the viral loop. Speaking of viral loop, that's the other thing that I wanted to kind of give you some tips on. And so what a viral loop is very simple. It's when you're on a social network casting that cast, you want other people who see it to also recast it, right? And so then you start to go viral with this application. And hopefully if you have hooks into your dApp, that's where it becomes like an acquisition vehicle. So paying attention to your viral loop is really important, mapping that out. For us, if you go try this, what we wanted to do, but we didn't have enough time, was once your art is created, we wanted some way for us to notify all the contributors of the pact to say, hey, your pact's ready, come and check it out. And when they do come check it out, then you could actually ask them to create a new pact or to share that result. And so right there, you can see like now we're completing the loop that, hey, you created something new. So there's now something new for people to interact with, or just sharing the result creates more exposure for that frame itself and hopefully for your dApp. So that's what we wanted to kind of add to the frame if we had more time. The other kind of mention that I have is just make sure you instrument or put telemetry for data in every part of your application so you can really track that viral loop and see, is it going viral? Are the people who post generating more people who post in general? So that's just a quick overview of what we did and just some of the tips for working with Farcaster. It's evolving very quickly, so you'll see like some of the best practices get outdated pretty quickly. But yeah, go give it a try. Warpcast.com/pixelpact is the way to go check it out. So that's it for me.
Oh, thanks for speaking about the link, because the pixel art was giving out for 404, and we just need to go to the Warpcast link. Sounds good. By the way, anything else that you guys wanna build on top of this? Like what's happening tomorrow, right? That we can expect?
Oh, for PixelPact? Yeah, it's we hopefully will continue to hack on it and do what we talked about, which is like creating some notifications, like a bot basically say, hey, your pact is done, and tagging people so you get a notification in your app.
Sounds good. Awesome. Thank you so much, Jackie. Thank you so much, Tony. And yeah, looking forward. Sounds good. So next, and thanks by the way to be like on a shorter time frame. Let me just untoggle. So next we have Tony Broyes. Let me just untoggle and toggle. So where are you? There you are, Tony. Tony, welcome. Please introduce yourself and let us know a little bit. Like I think you're sharing your screen, right? And
yes.
Yeah, looking forward. Let me know when you're sharing your screen that I can.
I do. Do you see?
Let me check. There you are. Awesome. So welcome, Tony. Please introduce yourself and take it away.
Okay, cool. Thanks, Francesco. I'm Tony Broyes. I work as a DevOps engineer at Infura. And so my project for the Consensus Hackathon is called Ford, and it's basically a new language, or the beginning of a new language to write smart contracts. And Ford is transpiled to Solidity. So just a quick recap on transpiler. So the idea is that you have code in some language and you want to end up with code in another language. And the way to achieve that is to first parse the source code of the original language, produce an abstract syntax tree, which is a tree structure representation of the code. And from this AST, reach the AST of the target language. So in this case, the target language is Solidity. And once you have the AST of the target language, then you can generate Solidity source code out of it. So what is Ford? So Ford is a personal project I started a couple of months ago, just a tiny general purpose programming language. I started to, basically like the best way to understand how to make a programming language, I guess, is to try to make one. So it has all the basic construct set like variable, function, if, else, for loops, but just that and not beyond. Like it doesn't have classes, it doesn't have interfaces, it doesn't have static type. And so the challenge for this hackathon was to repurpose Ford to kind of add features into the language that would allow to transpile to Solidity in the end. So the first problem was to tackle static type. And the way the easiest mechanism that I found to resolve that is to use native functions. So I introduced a couple of native functions into the language, into the parser, like this U8, U16, U32, or this native function for address here. And so by using that, when parsing the source code, the AST contains all the details that allow that the transpiler will use to know that this variable in particular is inside the integer of 1 byte, and that this variable here is an address, basically. Second problem also resolve about static typing, but this time is for function. So what works for variables obviously doesn't work for function. So here we have a function add to x, and the parameter list needs to be typed as well. And we need to know also the type of the return type. And in Solidity, you also have a visibility for function and state mutability. So the second mechanism that I propose for this hackathon, I have to find a solution that you can do in 1 week at hackathon, is letting the developer provide a companion metadata file where you can think of it like either file in C++ where you define like the function signature, and you let the transpiler know if this function is public or internal or private or external, and if it's a pure function or a view function, payable, etc. So that you can transpile properly to Solidity. So quick demo now. So here we have a contract written in Ford, contract playground, with a couple of variables that use primitive type. And here we have 2 functions, lambda and deposit. And we have a companion file here for this contract here. And what we get is the contract, the Solidity contract, which is semantically equivalent, that is generated here. I can run it. So first, the compilation just output the contract in Ford, the metadata file, then the transpiled Solidity contract, and then we have the ABI, and then the binary. So if I come back to this, and let's say I'm making some changes, just to prove that it works and it's not a fake implementation. Let's say I'm adding exclamation mark here, and why not making this function pure, because it's actually the case. And let's make the visibility internal and recompile everything. And so that transpiled properly, as we can see, we have an internal pure, all the changes are in place, and this compiles correctly to ABI and binary. And that's pretty much it for me.
Sounds good. Thank you so much, Tony. Any lesson learned from the hackathon, or any challenge that I hope you slept a little bit during this long hackathon, but anything that you want to share?
So you can use. You cannot use that right now. It's a POC, obviously, but I intend to continue on that. Add features, provide a website with a playground where you can input some Ford code, and it will output the Solidity equivalent and generate like ABI and binary online. I guess 2 usage for this is for pleasure, like if you're writing Solidity code on your day-to-day life, maybe having an alternative is always fun. And second, I thought of this as an educational tool, maybe to onboard new developers to smart contract programming, because in Solidity you have to make everything explicit. In Ford you don't need that; it uses the default for you, so you can have a chance to start. The learning curve is, I guess, is easier way from.
Sounds good. Awesome. Thank you so much, Tonya. And let us know if you're building cool stuff next.
Good.
So let me share my screen. I will untag you. Awesome, cool. Quick recap that I think we have a couple of minutes left. So for anybody that was not here, we kind of like recap on what are snaps, specific like section on from Christian around allow list requirement changes. We also did a cool session on 6963 with Eric, and then we had two great internal shout out dev team from Jackie, Tony, and Tony Broyes. And yeah, let us know also in the comments, both in YouTube or any place that you see the stream, if you think it's interesting seeing much more of those like demo build from the community more. And I think yeah, just quick to summarize, we will do the next community call end of June. And I don't know if anybody went to some of those cool X spaces. We ran a couple of those on attestation and on DeFi this month. And yeah, we're planning more of those spaces. And then also for anybody that is hacking or will be there, we're planning a couple of events heading to the main ECC Brussels event. So yeah, I think that's a little bit it. I think this is one of the first time that we finished the call on time, and yeah, I really looking forward to see everybody. Big shout out to everybody that organized, especially Eric and Lauren, and to everybody that spoke today, but most important, everybody that got engaged and asked questions. I think that's the most important part. So thanks everybody, and I see you guys in the next community call.